Okay, so we're looking at the second year Stats and Mechanics textbook, and we're on exercise 8E, which is integrating vectors. We're doing question 2. So we've got a particle P, and we're given its velocity as a vector, and we're asked for the distance. Okay, so we need to be quite careful here, because although this exercise is generally on integrating vectors, to get from velocity to acceleration for part B, I'm actually going to differentiate. So we've actually got integrating and differentiating here. Okay, but for question 2, part A, I want to get displacement, which is going to be the integral of velocity. So 3t squared plus 2I plus 6t minus 4j. So we need to integrate that with respect to t. So 3t squared is going to integrate to t cubed, or 3t cubed, then divided by 3. So that 3 will cancel, and the 2 will integrate to 2t. 6t is going to integrate to 6t squared divided by 2. So that will become 3t squared. Minus 4 is going to integrate to minus 4t, and then there will be potentially a constant. And even if you can look at the question and see that the constant is 0, still just write it there. And that constant is going to be an I and j vector, or could be an I and j vector. Okay, so you then need to go back to the question and read what information they've given you. So they'll often say when t is 0, it's at the origin. But here they've made it slightly trickier. So they've said when t is 2, p has a position vector of 9j. Okay, so let's just make a note of that. So when t is 2, r is 9j. So if we substitute that in, so 9, I'm writing I, right, so 9j, so r equals 2 cubed plus 2ti plus 3 times 2 squared minus 4 times 2j plus d. Okay, so all I've done there is substituted t is 2 into the I and j components. So 9j is 12i plus 4j plus d. Okay, and d is going to be a vector. So the constant is not 0 for this. So there is no I component on the left-hand side. So basically, d must be 9j minus 12i minus 4j. Yep, so I'm just taking, just subtracting that from the left-hand side. Okay, so the constant is going to be 9j, but let's do it I component first. So that's the only I component. So it's going to be minus 12i, and then that's the j component. So 9j minus 4j is 5j. So if I go back to r, and I collect, well, in fact, let's write it fully or unsimplified. So I'm going back to this line here. Okay, and I now know that d is minus 12i plus 5j. And the most sensible way to do that would be to bring all my I and j vectors together. So bring the minus 12 in with the coefficient of I, and bring the 5 in with the coefficient of j. Okay. So what is the distance of p when t is, or what is the distance of p from the origin when t is 0? So when t is 0, r is, okay, so when t is 0, that's going to be minus 12. I mean, I've actually kind of already got this here, but let's just write it out again. So it's going to be minus 12i, and if t is 0, that's just going to be 5j. So that's basically the value of my constant. And then just be really careful. It doesn't ask for the position, it asks for the distance. So just make sure you notice that. That's an easy couple of marks. So distance is the magnitude of the position or the displacement. So I don't really care that it's minus 12 because I'm squaring it anyway. So 2 squared plus 5 squared. Yes, I should have got that right. So that's 13, and we're working in meters. Okay, let's just check that. Yep, that's good. Okay. Right, so find the acceleration. Yeah, so this is where they've then mixed up a little bit, because acceleration is actually going to be the velocity differentiated. And the good news is that means we don't have to worry about plus c. So I'm differentiating this vector here. So 3t squared is going to differentiate to 6t, and the 2 is going to differentiate to nothing. The 6t is going to differentiate to 6, and the minus 4 is going to differentiate to nothing. Okay, so that's my acceleration vector. And I need to know what value of t to use. So they've not been nicer. They've not just said, oh, do it when t is 5 or whatever. They've said, find it when t is moving parallel to the vector I. Okay, so if you did exercise 8D, we've already done that, this could come up a little bit there. So I've already forgotten which way it's moving, right, parallel to vector I. So I is off to the right. So, okay, so j is up and I is to the right. So if we want to know when is it moving to the right, so an alternative would have been if they'd said when is it moving due east, that would have been basically the same question. So it's moving to the right when the j component of its velocity is 0. Yep, so it's going to be moving in the I direction if it's not moving up and down at all. Okay, so, and if they're talking about the direction it's moving in, that's going to be its velocity. That tells us how it's moving. Okay, so when is it moving parallel to the I vector? That's when its j component is 0, and that's the j component of its velocity. So I'm looking there. So that is going to be when 6t minus 4 is 0. So 6t is 4, so t is 4 over 6, or 2/3 of a second. So what is his acceleration then? Well, I've already done the acceleration vector. So when t is 2/3, the acceleration is going to be 6 times 2/3. So what's that going to be? 12 over 3. So 4i, and then just 6j. Meters a second, and it does not ask for the magnitude of it, so it will just be that vector. So let's just check their answers, and that's lovely. I think we are in agreement. Yes, we are.